So today we're going to talk about polygons and measuring interior and exterior angles of polygons. We're not going to talk about circles because circles are not polygons. So circles will come after spring break because circles don't have sides, so they're not polygons. We will be talking about interior and exterior angles. So take a second and think about what interior angles are. We've discussed interior and exterior before. Those words should not be new. So remember, interior is inside. So interior would be things like 2, 5, and 6. Exterior angles are outside. So that would be things like all these other ones. So everything that's not inside the polygon is an exterior angle. So interior has to be inside the polygon. And then exterior is everything that's outside the polygon. Types of polygons, you have some notes to take here. A polygon is closed, a closed figure with 3 or more sides. Not slides, just sides. A closed figure with 3 or more sides. Convex and concave, we barely touched on a little bit last semester. So convex is a polygon where all interior angles are less than 180 degrees. Concave is where one or more interior angle is greater than 180 degrees. And then a polygon with all sides congruent and all angles congruent is a regular polygon. Alrighty. So if you need more time, go ahead and pause that to get those notes. So you have a quick quiz. Oops. Let me move your little screen over. Wish that you could do this for real, but you can't. So I'm going to scroll through them and you can just write down your answers to see how well you do. So convex shape A, or sorry, that's not what this is. You are choosing which shape matches with convex. So using your notes, which shape is convex? Oops. I'm going to have to do the questions with you as we go. So convex. So remember, that's all interior angles are less than 180 degrees. So that's something like D and C. The interior angles are less than 180 degrees. C is convex, but it's a regular polygon. So we're going to go ahead and pick D. Concave means that the interior angles could be more than 180 degrees. So this angle right here on this little cross thing, this angle that's inside, this angle's 270 degrees. So that's what makes that a concave polygon. Regular, we discussed, has to be all equal, so that's that equilateral triangle. So that would be a square would be regular. Then you have like a regular pentagon, a regular hexagon, things like that. And then not a polygon is V. That does not fit the definition of a polygon. Alrighty. All right, so now we're going to talk about interior angles, and we have some directions. So if n is the number of sides of a polygon, this polygon has 4 sides. How many triangles are created in ABCD when the diagonal is drawn from one vertex? So it says to draw a segment from AC to find the number of triangles. So I can split this quadrilateral into 2 triangles. What is the sum of the interior angles of a quadrilateral? So if this triangle has 180 degrees, and this triangle has 180 degrees. Then I know there's 360 degrees total because 180 times 2 equals 360. How many triangles are created in the other one? Draw a segment from T to V. So I have 2 triangles again. Again, if I have 180 here and 180 here, I have 360 total. And this is a regular quadrilateral, which means that all of these are the same and all of these are the same. So if it's a regular quadrilateral and there's 360 degrees and they all have to be the same, then each one has 90 degrees. Pentagons. I have 5 in a pentagon. How many triangles are created? So drawing a segment from M to O and then from M to P, I can create 3 triangles. 180 in each one. So take 180 times 3, and I have 540 degrees in a pentagon. This is a regular pentagon. So again, V to X and V to Y. I can make 3 triangles, each with 180 degrees. I have 540 degrees inside the pentagon. But if I have 5 total angles that all have to be the same on this regular pentagon, each one has 108 degrees in it. So notice I'm only doing that to this side because this is a regular pentagon. So regular means that they all have to be the same. So I can only do that dividing by 5 if it's a regular shape. If it's not regular, then I can't find out how much each angle is. Like this on the left, I have no idea how much O, P, Q, M, and N are. I know together they have to equal 540, but I don't know how much each one is separately without further information. Hexagons. Again, we're going to look at hexagons have 6 sides. Let's draw some triangles, A to C, A to D, and A to E. So I made 4 triangles. Each one has 180 degrees. So that gives me 720 degrees total in my hexagon. H to J, H to K, H to L. 1, 2, 3, 4. 180 times 4. 720. So I have 4 here. 720. Because it's a regular hexagon, if I do 720 divided by the 6, so there's 1 for each one, it will be 120 degrees in each angle. So in my regular hexagon, each one is 120 degrees. So you have this on your paper, and the goal is that you've started to see some kind of pattern. If I take, so you're going to do as much as you can of this, fill in what you can of the names of the polygons, their sides, how many triangles are formed, the times 180 to find the sum inside. Okay, so this would be all the names. And then I want you to think about the number of triangles formed. Well, with a triangle, you only have 1 triangle formed. Remember, in a quadrilateral, you have 2 triangles formed. In a pentagon, you could do 3 triangles formed. What do you notice about this relationship? hopefully you see that all we're doing is subtracting 2. So with a hexagon, there were 4. With a heptagon, which is also sometimes called a septagon, like September, septagon, there would be 5. Octagon would be 6, nonagon 7, decagon 8, dodecagon would have 10 because 12 minus 2, we skipped 11. So an n-gon is just saying what the rule would be. So if I have n number of sides, I'm just subtracting 2. So a 30 would be 28 triangles. So now go back through and multiply everything times 180. And this is what your table should be so far. We'll come back and do the next column in a moment. So the rule for finding the sum of the interior angles of a polygon, that's what this means, the sum of, sum of interior it's 180 times n minus 2. So hopefully you have that written down already. So the question is, what is the purpose of this? What is the point? How can we use this information? Well, if I want to find any missing interior angle, I need to know how many degrees there's going to be. So this is a pentagon. And to find out how much there is, I would have to take 5 minus 2 times 180, or 3 times 180 to equal 540. So I know total I need 540. This is 90, so then I can add all of these together and subtract from 540. So you guys have done this before, but just with triangles and quadrilaterals. So now we're just kind of building onto that. So I add those up, I subtract from 540, and I get 135. So x has to be 135. Here's another example. If I know the sum of the interior angles of a polygon is 3960, find the number of sides. So I can use my equation, 180 times n minus 2 has to equal 3960. So you can solve this 2 ways, either plug that into your calculator, y1, y2, find the x, or solve it algebraically. Divide both sides by 180. N minus 2 has to equal 22. Add 2 to both sides, so n equals 24. We'd have 24 sides. So then, what's it mean for a polygon to be regular? All the sides are the same, all the angles are the same. So then, to find out how many angles each one would be inside, you would have your 180 times n minus 2, that finds how much is in there total, and then you divide it by how many angles there are. So then you can fill in the rest of the table by taking this number divided by this number. So do that. So this is what you should have gotten there. Sorry, I had to do this little arrow situation there for that. So you have take some time to answer questions 1 through 4 before you go on and watch the next video for exterior.